Now we're going to look at polynomial models with a volume type problem. A lot of these are going to be similar, but we may be solving for something different or it's set up a little bit different. So we have a square piece of cardboard that is used to create an open top box by cutting out a 4-inch square from each corner and folding up the sides. So what that would look like is you take a square piece of cardboard, so draw a square, and we want to cut out the corners. So we're going to cut out a 4-inch corner on every single corner. What that's done is given us a new base and some sides to fold up. So think about what a box looks like. It's not a perfect box, but you would have the sides that folded up, and they were each 4 inches. So when you take that box and fold, that makes the height of 4. The base is what's from the middle section here. So let's use a different color. We'll try green. Maybe that shows up. So that new base is right here. Because we've cut out the sides, or the corners at least, and folded each side up. So we started out with a square piece of cardboard. We didn't really know how big it just was a square. We can let that be X. But we cut stuff out, so this base is not X and X anymore. It's now been, it started out as X, and I cut out a 4-inch side there and a 4-inch side here. So we're left with X minus 8. And that would happen on this side as well. So this was 4 and that was 4. So the leftover piece is just X minus 8. Now we want to write a function that would express the volume. Well, the volume of a box, just to review, is length times width times height. So in this case, it's all three of these things being multiplied together. So I'm going to write it as 4 times X minus 8. And it's times another X minus 8, which is really just squared. But that would represent our volume. We don't have to multiply it all the way out, but that would be okay if I did. C says if the box has to hold 100 cubic inches, how big a piece of cardboard is needed. So now I know the volume is 100. I'm going to plug that into our volume, and we'll solve for X. So if I want to solve for X, I need to get into that square, but I can't do that until I get rid of the 4. So I would divide by 4, and that's 25. Now it's X minus 8 squared. We can square root both sides. Well, the square root of 25 is 5, but it's plus or minus 5 because we are doing the square rooting. And then let's just bring that up here. So X equals, if we add 8 to that, that's plus or minus 5 plus 8. So let's just see. Positive 5 plus 8 is 13. Negative 5 plus 8 is 3. So either we have a 13 by 13 piece of cardboard, based off of this 13 by 13, or a 3 by 3 piece of cardboard, 3 by 3. The problem is I can't have a 3 by 3. If I'm cutting out 4 inches on each side, there's no way that we had a 3 by 3. So it has to be that it was 13. So we needed a 13 by 13 foot piece of cardboard. Oh no, these are inches. Okay. So 7, we have a large plywood box that's going to be created. Its length is 9 feet greater than its height. Its width is 4 foot less than its height. It is to have an open top, so it's not closed in. It's kind of similar to what we had here, but but I'm not doing this cardboard thing where we're cutting out corners. It doesn't say anything about it. We just already have the box. So let's draw a picture of our box. It is 9 feet, the length is 9 feet greater than the height. So if our height is, let's say, x, and the length is 9 feet greater, let's let this one be the length. I pretty much always do this one. So x plus 9 is the bottom one there. The width is 4 foot less than the height. So if the height was x, then the width is x minus 4. Now, that gives us enough information to find the volume. So I'm going to write this volume function out in terms of x. So volume is length times width times height, but we're all multiplied together. So if it's prettier, we would write it as x times x minus 4 times x plus 9. We don't have to multiply that all the way through, but we can. In C, it says the dimensions of the box has a volume of 180 cubic feet. So now we know the volume is 180. And I can set up an equation, but I don't think we've run into any of these polynomial functions like this yet, because it's not equal to 0. And we need to solve a polynomial by factoring and getting it equal to 0. We can't do that right now until we've multiplied all of that out. So let's do that first. And multiply these two binomials. X times x is x squared. We multiply the outside, get 9x. Inside's negative 4x. So 9 minus 4 is positive 5x. Negative 4 and 9, it's going to be negative 36. If I distribute my x, we see x cubed plus 5x squared minus 36x. That was our goal. We wanted to multiply that out because we need to get this equal to 0. And now I can subtract 0. Or sorry, subtract 180 to get 0. Okay, I'm kind of running out of room, so let me bring this up here. This is a cubic function equal to 0. There are 4 terms, and the way that we've seen how to simplify that is to group. So I'm going to group the first 2 and the last 2. This would say 0 equals x squared is a GCF in the first group, leaves us with x plus 5. And then a GCF in the next group, well, hopefully it's 36, but let's see. So 180 divided by 36 is 5, yeah. So I can pull out a negative 36 and be left with x plus 5. We wanted those two things to match. So factoring by grouping gives us x plus 5 times x squared minus 36. The second factor will continue to factor. So that'll be x plus 6 times x minus 6. And it's completely factored now. That lets us use our zero product property. So x equals negative 5, x equals negative 6, and x equals positive 6. There's no way that we can have a negative height. So these first two do not make sense, but the last one would. So the dimensions here, you want to kind of specify what we're talking about. So the height we know is x. In that case, it's 6 feet. the length was specified for us. So the length is 9 feet greater. So that's this one here. So 9 feet greater would be 15. The width was 4 foot less, which makes that 2 feet. Okay. Number 8 here, we have another open top box, and it's going to be constructed by taking a piece of cardboard 20 centimeters by 40 centimeters and cutting out squares from the corners. So this is kind of just like what we had earlier, except now we know the dimensions of the cardboard. We have a picture that shows a rectangle that is 20 centimeters by 40 centimeters. We're going to cut out squares of length x. So the difference between 8 and 6 is that this one told us what size corner we were cutting out, but not the original dimension. This one tells us the original dimension, but not the size of the corner. So I'm still taking out a square out of the corner, but it's x by x square. So this would also be an x by x. We turn that into a box by cutting those out and folding up the sides. Okay, so something like this. And the sides that folded up that are coming from the corner. So that means that the height is x. What's left over is this base here. So that would be what's the base of this new box. Okay, so it's not 20 anymore because we cut out some sides. It was 20 and we took away an x and an x from that side, so it's minus 2x. This was 40 until I cut out some x's, so it's 40 minus 2x. There's our whole picture. You would not want to do this without trying to draw a picture. In fact, if you do draw a picture and you get at least the picture right, maybe that's some points on a test. All right, A is writing the function in terms of volume, of volume in terms of x. So the volume function would say x times 200, or 20 minus 2x and 40 minus 2x. Then we have, what is the domain of this volume? So the domain here, if we think about practically what we know, there's no way that I can have a negative length or negative measurement of length, width, or height. So that would mean that each part of these has to be at least 0. So x would be greater than 0, 20 minus 2x is greater than 0, and 40 minus 2x is greater than 0. If we solve those, well, that one's already solved, but this one, negative 2x is greater than negative 20, so x, flip our inequality because we're dividing by negative, is less than 10. And then we do it here again, negative 2x is greater than negative 40. So x is less than 20. So based off what we know, x has to be greater than 0, but less than 10 and less than 20. This second one is kind of where we get confused, because think of a value between 10 and 20, maybe something like 15. If x is 15, then this would mean that's 20 minus 2 times 15. 2 times 15 is 30. So 20 minus 30 would be negative 10. There's no way that that could work. So really we're stuck between 0 and 10. So our domain would be parentheses 0 all the way to 10 with the parentheses as well. We're not going to put brackets there because if it was exactly 0, it wouldn't have a volume. And then C says, what would the maximum volume be? Well, we have a polynomial function, so think about what the graph of that looks like. It's going to have a 0 of 0, another one at 10 from that factor, and then we solve that one, we're going to get another 0 of 20. And we would have to kind of know the behavior, the end behavior, but we would see something that goes like this. If I wanted the maximum volume, if I had a graphing calculator, it'd be super easy. I could just plug that in, find the maximum. But for our class, we don't have that ability to do on tests. So we would not be able to be asked this type of question on a test. All right. For right now, we would need a graphing calculator. Or Calc 1 to solve for the maximum. Now, one way we could prevent that, or circumnavigate it, is to actually give you the graph. We could say, you've done all this work, but here's a graph of the function, and it shows this maximum of 4.226, comma, 1539.60. So if we gave you that graph, you could use that to interpret things. What that tells us is that our input is 4.226. Our input here is x. So x equals 4.226, and the output, which is y, or in our case v, and the output was the maximum volume. So the maximum volume is 1539.60. So 1539.60 cubic centimeters, because our dimensions were in centimeters and it's talking about volume. So that's a way that we could get around not having a graphing calculator, is actually giving you a graph. So if you're working through some of the lab manual, you will have to plug that into Desmos and maybe find your maximum. But most of the stuff that you'll be asked, you can solve algebraically, like a quadratic, or we could have a cubic equation and solve that. Okay, so we jump to the last part of the notes here, last page. Number 9, a rectangular piece of cardboard is 10 inches longer than it is wide. And we're going to cut out a 4-inch square again. So, draw a picture. We start out with a rectangle that's 10 inches longer than it is wide, so maybe that's x, and this is x plus 10. But we're going to cut out a 4-inch square. So this is a 4 by 4. Okay. We use that to form a new box by folding up the sides. So let's look at what that new box's dimensions would look like. The height is 4. That's what is coming up on the sides. But the new base started out as x, and we cut out 4 and 4, so it's x minus 8 now. This one, the length was x plus 10, and I cut out 4 and 4, so I'm still cutting out 8. Well, x plus 10 minus 8 is going to leave us with x plus 2. So write a function that can be used to model the volume of the box. Our volume is going to say 4 times x minus 8 times x plus 2. C says if the volume is 500 cubic inches, what would the dimensions of the box be? So now I can plug 500 in here. But just like we saw with the volume previously, we needed to get it equal to 0. So I'm going to multiply out this, and it will say 500 equals 4. Let's multiply the binomials first. That's x squared minus 6x minus 16. We distribute our 4. That's 4x squared minus 24x. 4 times 16, 64, so minus 64. And then subtract 500. So now it's going to be equal to 0. So I subtract 500 from the negative 64, which gives us negative 564. And we have a quadratic equation. We want to find out what x is because we're trying to solve this equation. We can solve a quadratic by factoring or using the quadratic formula. This is one that I would maybe just go ahead and use the quadratic formula on because this is such a big number, but if we had tried to factor, I could divide this out. So let's say that's 6x again, but 564 divided by 4 is 141. And if I tried this this quadratic, there's nothing that factors 141 that's going to end up giving me 6x. So this doesn't factor any further. Let's just go to here. So x equals negative b, would say negative 24, and for b, plus or minus the square root of b squared is negative 24 squared minus 4ac, so 4 times negative 564, all over 2a, so 2 times a is 4. And that's what we're just going to simplify. Let's see, so that's 24 plus or minus square root of something over 8. And plug that into our calculator. So negative 24 squared. Right, 900 or 9,600 goes inside the radical. We would simplify all of that. So this ends up being, let's just say, 24 plus or minus this square root of 9,600 is 40 square root of 6 over 8. And then we can simplify that again. So 24 divided by 8 is 3, and 40 divided by 8 is 5. So I get 2 answers. 3 plus 5 square root of 6. Well, is approximately 15.25. Then we do 3 minus 5 square roots of 6 is approximately negative 9.25. That one wouldn't make sense. Can't have a negative 9 length. But we could have x is 15.25. So x equals 15.25. And then what would the dimensions of the box be? We could plug those x value in. So the box is 4 by, let's say, 15.25 minus 8 is 7.25. And plus 2 is going to be 17.25. But then what would the dimensions of the original sheet of cardboard be? So the cardboard was x by x plus 10. So 15.25, and these are all inches. But add 10 to that, so 25.25 inches. So it just depends on what the question asks us. They may only ask what is the dimensions of the box, or it could say what's the dimensions of the original cardboard, but they may not ask about both of those, probably just one of them. All right, the last thing here is a revenue type problem. So a man owns a hot dog stand. He usually sells about 300 hot dogs per day at a price of $2 per hot dog. He notices that when he raises the price by 10 cents, he's going to sell 3 fewer hot dogs. So every time he raises it 10 cents, he sells 3 fewer hot dogs. We want to create a function to model the man's revenue based on the changing of the price. Revenue is always just price times the number of things that you sold. So originally he would sell 300 and get $2 per hot dog, so 300 times 2 is 600. He'd originally get $600 for his revenue. But we're going to change the price sum. So the revenue is, let's see, the price started out at $2. And we're going to add 10 cents each time. So that would mean that I have started out with the number of products sold was 300, and I sell 3 fewer hot dogs, so minus 3x. And x is just our amount of hot dogs. So that tells us the price here and the number of hot dogs sold. Okay, so find the price that he should charge for his hot dogs, so that this will be a maximum revenue. If I multiply that out, 2 plus 0.10x times 300 minus 3x. This is something that turns into a quadratic in standard form. So 2 times 300 is 600. 2 times negative 3x is negative 6x. 0.10 times 300. If you need a calculator for that, that's fine, but 0.10 times 300, whoops, 0.10 times 300 should just be 30. So plus 30x minus, and then 0.10 times 3 is just 0.3x squared. What we see is 600 minus 36, oh no, minus 20, plus 24. Goodness. All right, minus 0.3x squared. There's our quadratic. It's not in standard form exactly because it's not ax squared plus bx plus c, so we could change the order if we needed to. But we just want to find the maximum. So that's negative b over 2a to start that out. Negative b is negative 24 over 2a. Well, a is negative 0.3. So you just want to pay attention to what order is. We've had that on previous tests where it's not exactly in the same order or standard form order. But let's see what that is. Negative 24 over 2 times negative 0.3 is 40. So if x is 40, then we want to find the maximum based off of that. R is 600 plus 24 times 40 minus 0.3 times 40 squared. So 600 plus 24 times 40, and then minus 0.3 times 40 squared is 1080. So this is saying his maximum revenue is $1,080. But the question wanted to know, what price should he charge? And X is 40, but that doesn't mean he's charging $40. Look back at what we started out with. The price was 2 plus 0.10x. So the price would be 2 plus 0.10 times 40. In our case, let's plug that in. 0.10 times 40 is 6. So he should charge $6 per hot dog to get a maximum revenue of $1,080. And he's going to lose some customers, but he's going to be making more money.